Hi dear students, welcome to the next chapter from physics first year. First chapter we have learned about the units and dimensions, and in today's sessions we are going to the next chapter, laws of motion. This is a chapter I am going to discuss from here onwards. Okay, so laws of motions, units and dimensions we have learnt. There are different units and different dimension formula. Most of the units whatever we have learned will coming to picture in this chapter also. So let's start to study. Here concept is too much important. There are many things we need to remember in units and dimension. Here I can say almost 98% things you don't want to remember, but everything is concept based. So without wasting the time, let's start the chapter called, next chapter is laws of motion. In school standard also you have learned different laws from Newton's first law of motion, Newton's second law of motion, Newton's third law of motion. Same thing we are going to learn here also, but in an elaborated way. Okay, so let's start with the Newton's first law of motion. Write out the heading on your notebook, Newton's first law. Newton's first law of motion. What is Newton's first law? States that Newton's first law states that if a body is in rest position, then we need to apply a force to move the body. This is one definition. Another definition, if a body is in a continuous motion or in a uniform motion means the same speed motion, then to alter its speed, either to increase the speed or to decrease the speed or to stop the body, we need to apply something called extra. That something is called force. So two definition of force I told. If a body is in rest position, if I want to move the body, then I want to apply force. For example, this is a pen which is on my hand and it's in the rest position. If I want to move the pen towards left or right, wherever, so I need to apply some push. Then if I apply this push, the pen will be getting moved. So the pen is initially in a rest position, and to move the pen I am applying some force, and that is called one definition of force. Another example, if a body is in an uniform motion means if a body is rotating with a constant speed, then if I want to alter the speed of the body, I have to apply force. Suppose if I want to increase the speed of the body, I have to again apply force. If I want to decrease the speed, I have to apply the force to hold it down. Or if I want to stop the body also, I have to apply the forces. So force are going to apply for a uniform motion body, either to increase the speed or to decrease the speed or to stop the body. So this is called Newton's first law of motion. Okay. So in short, rest body to motion, we need to apply force. For a body in uniform motion, to increase the speed, to decrease the speed or to stop the body, we need to apply something called force. This will be written in an Ncert textbook in a beautiful way, in a beautiful English. If a body is in continuous motion or body is in a rest position, unless until applied by an external force, this body is in that state itself. Which means that what? If a body is in rest position, it will be there in the rest position. If a body is in the motion state, it will be there in the motion state, unless until if you are not applying any external force. Okay, so we can write the definition. The body is in rest or in uniform motion until when? Unless applied, unless until applying an external force. So whenever we apply an external force, what will happen? The state of the body will be getting changes. So body is in the rest position or in uniform motion unless until I am applying an external force. So if I started to apply some forces, if a body is already in rest position, the body will start to move. And if the body is already in a constant speed, which is called something called uniform motion, if it is in constant speed, what will happen? I can alter the definition. So this is called force. So Newton's first law is giving something called qualitative definition of force. This is my first point. Second point, Newton's first law. Newton's first law giving qualitative definition of force. Qualitative definition of force. What is qualitative? Quality will be there. Something will say quality, something will say quantity. Qualitative definition in the sense the first law is stating what is called a force. If somebody is come and ask me, hey, what is called force? Then I will say this is called force as per Newton's first law. That is called a qualitative definition, sir. And something called a quantitative definition. Quantity means the measurement, right? Quantity. So how much I can measure. So Newton's second law will be there. That's what we are going to learn as a second part. So Newton's second law is giving quantitative. What is the amount of force? How we can measure that force? That is given by Newton's second law. First law is not giving any method to measure, but first law states that okay, this is called force. That's what we are doing. Newton's first law giving the qualitative definition of force. Okay, so we know now there are two types of forces will be there. Forces F are two types of forces will be there. And first forces is called contact force. First forces is called of contact force, and second set of force is called non-contact force. Contact force means like direct connections are there. Like for example, an example of a contact force is called a frictional force. Frictional force. Frictional force means what? Friction means if a body is moving in one direction and an opposite forces is applying to prevent the motion. So there is a surface, right? Friction is exists on the surface. If a body is there only, body is moving in this direction, friction will be acting in the opposite direction. So there is a connection, sir. What is called a non-contact force? Example for a non-contact force is called something called gravitational force. Gravitational force. What is called gravitational force? Gravitational force means here I have a pen. If I just drop the pen, it's falling down. So any connections with the ground? No connections with the ground, but it is going towards the ground. So there is no connection between the pen and the ground, but itself there is a force will be there. Because of the force, it is attracting towards the earth. So contact force and non-contact force. There is no direct connections between these two bodies. So we learned about Newton's first law, definitions of law, and this is giving the qualitative definition, and there are two types of forces will be there. We'll move to the next part. Next part is called Newton's second law. So first law we have learned the definition and the concepts, and this is giving first law is just to mean to say okay, if somebody will come and ask, hey, what is called force, then I have a way to say, oh, this is called force. So first law will be giving the definition of the forces, and we have something called Newton's second law. Newton's second law. Newton's second law giving first point, it giving the quantitative definition of force. Quantitative. The first law is qualitative, second law is quantitative. So quantitative definition of force is given by Newton's second law. And what is Newton's second law? It states that, as I told, if a body is in rest, to move that I need to apply the forces. If a body is not in rest position or it is moving with a constant speed, then I have to apply the forces to halt the body. So what this law states that force is proportional to rate of change of momentum. Rate of change of momentum. Momentum means what? Momentum is a term which is called a momentum. Okay, first I will define what is called a momentum. Momentum is equal to mass into velocity. Masses. Here I have given a term called rate. I have given a term called change. So with respect to the momentum term, in this statement, rate and changes are extra. Momentum is called mv. So momentum is called mv. So rate means divided by time. Change means what? Means momentum is mv. So how to create a change in momentum? Change in momentum is delta p. Normally momentum is representing using a letter called P. P is equal to mv. And delta P is called change, difference. So that delta P is called m into mass is always constant in the entire planet. Okay, not only in Earth, if you are going to moon, everywhere mass is constant but weight is changing. So mass is fixed, velocity will be changing. So change in momentum, rate means divided by t, delta t. So F is proportional to dp or delta p divided by delta t. Proportionality sign is replaced with a constant which is called k, and k into delta p divided by delta t. This is called Newton's second law, and k value is equal to 1. It's just a constant, nothing, it has no dependencies with the medium or any other factor, just a constant. So F is equal to delta p divided by delta t. In some textbook, if you refer, you may see k into dp by dt. Both are correct. D or delta. D is called a difference. Delta is called a difference. So in any way, if you have written both ways, it is correct. Nothing wrong will be there in this case. So k into dp divided by dt. This is called Newton's second law. And additionally, this delta p or I can say which is also called dp, I told, right, this is equal to m into difference of velocity. There are two velocities will be there. If a body is starting, for example, you can consider like a bus will be there in a bus stand. A bus is started to move. So initially when bus is starting, it is on the first gear and it is just accelerating and moving, right? So initially speed will be less. Once it is entering to highway or in a vacant road, what will happen? Speed will be increases. So the initial speed is called a letter called u, and the final speed after some time, its speed is letter called v. So u is the initial speed and v is the final speed. So delta v is final velocity minus initial velocity. So here v is called final speed, final velocity, and u is called initial velocity. Initial speed you can say, or you can say initial velocity. Speed and velocities are different, but yeah, in short it is called speed. So delta p is equal to m into v minus u. If you substituted will be this one. I know k is equal to 1. So what you will get? M into v minus u divided by delta t. Delta t is a difference in time. Okay, so I can written as delta t. Okay, m into v minus u divided by delta t. One more point I would like to convey here. What is that point? In the sense is like velocity in schools classes also, like I don't know, like 8th or 9th or 10th or you have learned, right? Difference in velocity by difference in time. Okay, I am writing F is equal to m into this. I can written as delta v divided by delta t, right? This delta v only we have written v minus u. So which is called delta. Difference in velocity by difference in time is called acceleration. So F is equal to ma is the Newton's which law? This is the second law of motion. This is the Newton's second law of motion. This is not 100% correct. Why I am saying that it is not 100% correct means here I assumed that. Here I assumed that m is constant. M constant on m is not changing. That is the assumptions I have made it here. But it's not always like that. There are situations are there. This m is keep on changing situations are there. Okay, if I am taking this pen, I am saying this pen will be equal to 100 gram. If I keep this pen to moon, then also it is 100 gram. But there are some situations that you will see while we are doing some questions, some problems and all, you will come across that there are some situations m will be also changing. So in that cases, in generally I can written as F is equal to m into dv by dt, one case, or I can say v into dm by dt. This is the final most popular equations called Newton's second law of equation. This is the equation I like comparable to this one, because this will be cases will be it is more flexible cases. How this is coming in the sense means here we have written k into dp by dt, correct? Here momentum only we are differentiating, so m into delta v. Here I told delta p is equal to dp is equal to m into v minus u. Delta p is equal to m into delta v. So instead of writing this part like this, I have an options to write. Here what is the assumptions I made? I made an assumption called m is constant. Okay, now one point, if m is not constant, I can say delta p is equal to v into delta m. In this case, what is constant? V is constant. In maths, there is one principle is there. If one quantity is constant, you will learn differentiations. Differentiation, the change, if it is a number, then maths like addition, subtraction and multiplication, division, these are the different mathematical operations. Same way, there are two other different mathematical operations are there, and one mathematical operation is called integration, another one is called differentiation. If you are doing a differentiations for a quantity of a constant number, you will get it as 0. In this example, I told if mass is constant means mass will come out. So dV by dt will be there. If mass is constant means difference of mass. So that is 0. So this factor is not there if mass is constant. Another way, if mass is not constant but velocity is constant. So this term will come or this term will come. Can you tell me? Mass is changing means dm should come. So dm by dt, velocity is constant. So this term will come. So as per Newton's second law, this is a generic equation of Newton's second law. If velocity is changing, first term will come, mass is constant. If mass is changing and velocity is constant, then second term will come. Both cases, mass is changing, velocity is changing, there are also possibilities are there. If mass is changing and velocities are changing, such cases may also come. In that cases, both term will be there. So depends upon the question. Either we have to write f is equal to m into dv by dt in one case, or we'll write f is equal to v into dm by dt in another case, or we'll write f is equal to m into dv by dt plus v into dm by dt. That's what I told. This is a general formula because this is fit for all your use cases. And if mass is constant, what is the value of dm by dt? Difference of mass. Mass is a constant. It's a number. What is the difference of that number? Difference of that number means that number minus that number itself. So it is 0. So m into dv by dt will come. What is dv by dt? Velocity by time is called acceleration. If mass is constant only, f is equal to m into dv by dt will come, which is equal to f is equal to ma. Otherwise, this equation is not correct. So this equation is correct. So there is a conditions will be there. Mass is constant. If mass is constant only, f is equal to ma I can use. If mass is not constant, I cannot use f is equal to ma. I have to use f is equal to v into dm by dt use cases. Okay, hope you understood Newton's second law of motion. Okay, of course, you know what is the last one. Last one is called Newton's third law of motion. Okay, so Newton's first law we have learned the qualitative definition of forces, and in Newton's second law we have learned how to measure the force. For that, Newton is given as a beautiful equation. F is equal to m into dv by dt plus v into dm by dt. Mass constant dm by dt is equal to 0. Velocity constant m into dv by dt term is equal to 0. So Newton is given as a beautiful methods to measure what is the value of forces. Okay, now we are, so qualitative definitions we learn, quantitative definition also. Qualitative means somebody will come and ask, hey, what is called force? Hey, I have a Newton's first law. My Newton's first law will be giving the definition of forces. What is quantitative? Quantitative means, oh, you told this is called force. How to measure? You can use my second law. Newton's second law is giving quantitative definition of the forces. M into dv by dt plus v into dm by dt. This is the first equations I am giving to your basket. We'll go to the third one. Third one is the most simplest one, Newton's third law of motion. All students who are studying physics will know, right? The first point, every action, everybody know this law, that is the beauty of this law. Every action there is equal and opposite reaction. If you are giving every action, every action there is equal, and opposite called reactions will be there. And my another point is like action and reactions are acting on a different body. Two things will be there, right? Action and reactions will be there. Both are acting on a different body, not on the same body. Action and reactions are acting on a simple body. Let me tell you an example to this one. Okay, so if I have a body like this, and body of mass is called M, and we are applied a force, this is will be there in a surface, this is rest position. What this will give, this will call something called a weight, and this weight is called action, and this weight is called action. So every action, what is given, there is equal amount, equal will be there, equal and opposite, so opposite directions. This is called a reaction. Some textbook will written as R, in some textbook it will written as N, both are same. I am written R bar N, you can use R is called a reaction. Some textbook will use N is called normal reaction, both are same, one and the same. So R is actually equal to N. Action you can say, reaction you can say, or you can say a reaction is equal to action. Okay, so what is the formula? Reaction, or you can say N, you can use any letter. Okay, I will use it either R, I will use it N, depends on moving forward, anything it is fine. So is equal to are equal and opposite. So R is in the upward direction, mg its weight, this is called a reaction, and this is called a reaction. So this is called reaction, or this is also called what? Called normal reaction. Both are one and the same. Okay, so every action there is equal and opposite reaction. Action and reactions are acting on a different body. Why it is saying like a different body? Action and reactions are acting on a different body. What is mean by different body? See, action is acting where? This is a body and this is resting, where action is acting on the ground, and reaction is acting where? Reaction is acting on this block. Action is acting on the ground and reaction is acting on the block. That's what it is saying. It is acting on different body. Different body means action is on the ground and reaction is on the mass. So both are acting on a different body. So three laws we have learned: first law and second law and third law. And next we will move to do certain cases based on all the laws, all the equations, all the things what we have learned. Based on that we will go to learn a next concept, and that concept is called free body diagram. Okay, we'll move to the next topic, and which is called a free body diagram. So we have learned about three laws from Newton's first law, second law and third law. Now we are going to apply all this concept whatever we have learned in something called free body diagram. Okay, so write on the heading called free body diagram. Free body diagram. In short, I name this to FBD. Some textbooks are referring, but some textbooks are not referring, but I am writing FBD in short. Free body diagram. I can say if you understand how to draw the free body diagram, this is the crux of this chapter. This is a soul, or this is a main heart of this chapter, is called free body diagram, because there are numerical based questions are asking a lot of from this area based on certain diagrams, based on certain conditions, and you have to draw the diagrams as such like that. So there are certain rules are there to draw the free body diagram concepts. Okay, so there are three rules actually you must know, so that these three rules we are applying to the while we are drawing the diagram. Okay, so first we will write this three laws, and not the three rules, it's a three rules actually. And we'll write the three rules, and once we are going to our first and second and further examples, we will get to know, okay, how these rules can be applied. So let's first write the first law. Contact force, write down, contact force are always towards the body, are always towards the body, are always towards the body. Point number one. Point number two, tension force are always away from the body, away from the body. This is the second one. Third one is the most important one. Tension into acceleration. Okay, this is called TA. T is called tension and A is called acceleration. So tension into acceleration is constant. Constant means it's not changing, that's all. Okay, we can also written as this in additionally, T1A1 equal to T2A2. Okay, if you have T3A3 will be there and so on. So T3, so generally T1A1 equal to T2A2 and T3A3 T4A4. any number of terms you can consider this. So these are the three laws. Contact forces are always acting always towards the body. Tension forces are always away from the body. Contact forces towards the body. Tension is away from the body. So that's too simple. But the third one is tension into acceleration is a constant one. So these are the three rules with which we are use it while we are doing some problems. Okay, now we'll directly jump into some examples, some concepts, and these concepts are really required while we are doing some questions. Okay, so we will write it as something called some different examples. Okay, this is not like as such it's not a numerical problem, but we will learn some concept via some examples. So that examples will help you to solve the problems. So let me see example number 1, my first examples to you. Okay, there are different structures or different problems are there. First one, in example number 1, suppose I am assuming I have one block of mass m, I have second block of mass m, and which is on the floor. We will also learn how to draw the free body diagram also for this kind of question. This is M1 block and this is M2 block. For example, I am applying a force called F. Why I am applying the force? Because of this force M1 and M2, I am assuming this is a sufficient amount of force will be there so that M1 and M2 will move towards right side. Questions will come like this one. Okay, here if two bodies are connected each other, if there is a physical connection, there exists something called contact force. Okay, contact force either we can represent using small letter f or we can represent using called N. Okay, normal reaction, our concepts we can use it as N or we can use it as small letter f, whatever you know you can use it. Here I am using the letter called small letter f, or you can use it also called N, both will be the same. Okay, now what we have, once we got the questions, so what we have write mean free body diagram of M1, first body in the free body diagram. What we'll do, we will place the body called M1 like this. Okay, now we have to we know the existing force is called F. This is resting on the surface. So free body means here there are two bodies are there, and we are making the body free from other bodies. So how many bodies? Two bodies will be there. So M1 body, now I am going to make it free from other body, which means only M1 is exist. Now I am going to mark the different forces which are acting on the body of M1. What are the different forces which are acting on the body M1? So these two forces I am going to mark it. First one is the weight of the body will act in the downward direction, and this weight is marking as M1G. This M1G is called, as per Newton's third law, M1G is called action. So we have a reaction. I am marking that reaction as N1. Okay, for the first body. Then what all the things will be there? We have to mark acceleration also. Acceleration means this body is moving towards the right side. So acceleration. Only these things. And here we two bodies are in connection. So we have our first law. What is the first law? States that when two bodies are in contact, okay, there is something exists, it's called contact forces, and this contact forces, what the first law says, it's towards the body. So I'm going to mark the contact forces, which is called small letter f, towards the body. So this model is called free body diagram. We are marking all the forces acting on a body plus acceleration. Okay, so this is one force, this is already exist there. This is not my contribution, it is the question contribution, and this F is my contribution because I know a contact is there. Whenever a contact is there, contact forces are towards the body. This arrow mark or the direction is important while we are drawing the free body diagram, as well as while we are solving the numericals. So M1 weight is always downward. This is called action, and we have something called N1. N1 is acting in a opposite direction, which is called reaction. Now the main concept. Now next, once we have drawing the diagram, the next step is we have to write the equation for this one. Okay, so first we will write an equation for this one, or you can draw the second free body diagram also. But before going to do that, I am writing the equations. The equation states that total force along x direction is equal to mass into acceleration. Mass into acceleration. Then your conditions under one conditions will be there, provided okay, provided body is moving with non-uniform motion. Okay, if this is exist only, this acceleration is available. As I told in the last class where Newton's second law, acceleration is v minus u divided by t. V means what? V is the final velocity and u is the initial velocity divided by time. Non-uniform, here I used some word is called non-uniform. What is this non-uniform indicate? Non-uniform means final velocity, end velocity and initial velocity both are different. If it is different, only acceleration is exist. Instead of writing this one, if I am writing provided body is moving with uniform motion. Uniform motion means what? V and u are same because it is moving with the same speed. Same speed means starting speed is equal to ending speed. In that case, what is the value of acceleration? 0. So this equation is not applicable. If a body is in rest position, so we will write the second set of equation. We can write sigma fx equal to 0. What are the conditions? Which means acceleration is equal to 0. Can you tell me? Provided body is in rest. One case it is not moving. Okay, it is not at all moving means no acceleration, rest, or what is in rest, or moving with what? Uniform speed, or moving with uniform speed. So we have two conditions are there. Either the body is moving with the non-uniform motion starting from rest and accelerating, then sigma fx equal to ma. In another cases, if body is in rest condition, so this factor is important. Body is in rest or body is moving with the uniform speed. Uniform speed means v is equal to u. To understand it for easily, you write v is equal to u. Hence, a is equal to v minus u divided by t is equal to 0. Okay, this is a concept. So similarly, here we have written for sigma fx, same way we have to written for sigma fy. So sigma fy will be equal to ma and sigma fy will be equal to 0. Here sigma fx indicate the force along the x direction, whether it is positive x or negative x. Sigma fy means along the y axis, right? We have two y axis will be there, upward and downward, positive y and negative y, positive x and negative x. So that are the things we have to write the equation for this one. So now we know the concepts. Okay, we have to write the formula, the respective formula for this equations. Okay, so I am clearing this side. You can pause the video and you can complete the notebooks. Okay, and here now I am writing, now I know acceleration is there because initially the block is at rest and it is not moving. Now the block is started to move. In this case what will happen? In this case what will happen? We will write the equation. So I am writing sigma fx equal to ma. What is the value of m will be here? 1. m1 body. ma is a general, m is called mass, here m1. Sigma fx, whatever going in the positive direction, this is going in positive x-axis, right? We have the sign conventions will be there. Sign convention means positive x, this is minus x, this is positive y, this is minus y. Whatever moving in the positive x, you consider as positive. That's all. So this f is positive, and this f is moving in negative x direction, right? So it is minus f. So that is the only forces are acting in the x direction, which is equal to m1 into acceleration direction. Okay, mass is a constant, it's a scalar quantity, it has no direction, it has only magnitude. Now acceleration is a vector quantity. Vector quantity means quantity which have a magnitude value and a direction value. Velocity, we will ask what velocity it is moving. We say 30 meter per second velocity it is moving. Then we'll ask what direction he is going. He is going to the left, he is going to right, we'll say, right? So that is called vector quantity. So acceleration is also a vector quantity. Acceleration means increase in speed is called acceleration in very simple way. If a car is started, gear, first gear, second gear, third gear, so car is increasing, that is called accelerations. If we have seen some traffic signal and we are applying the brake, so what will happen? Speed will be gradually decrease and going to stop. That is called deceleration. Opposite of acceleration is called deceleration. Okay. Okay, so here, so that is not important, at least in this context. That's what I am not dig into the topic. So acceleration a is also in the positive x direction. So it is m1a. This is our first set of equations from this diagram. So, and the next set of equations along the sigma fy. Okay, sigma fy, while we are, so this is our first set of equation. Second set of equation, sigma fy. The body is moving like this. No, the body is moving only like this because I am applying force like this. So here in this case, body is not moving in vertical direction, body is not jumping down and up. So acceleration equal to 0. In that case, I will write sigma of fy will be equal to 0. And fy equations I will write n1. This is going upward. Upward means positive y direction. So n1 is positive, n1. And m1g is going downward, minus y direction. Minus y means minus. m1g is equal to 0. Why it is equal to 0? Because body is in rest with respect to y direction. Body is moving only with respect to x direction. That's what we have written. We got two equations, equation number 1 and 2 from this one. So from here we can directly write n1 equal to mg. That's what we are saying. m1g is called action, n1 is called reaction. So action and reactions are equal and opposite. That's what the same things we have learnt in Newton's third law of motion. The same thing will be here also. Okay. So free body diagram of m1 is over. Next we have to do it for what? Free body diagram of m2. So let's move. Free body diagram of m2 we have to mark. Okay. So m1 body, so each of the body, in this question there are two bodies are there. In some question there are three bodies are there. Three bodies will be there, means three set of diagram has to draw. So next one is free body diagram of m2. Free body diagram of m2. So we'll draw the diagram called M2. What all the forces will be here? Here contact. So contact force, same contact force F. Okay. The contact force which is applied on M1 is called F and back to M2 is also called F. Both are equal. Both are same contact force F. Any other forces? Yes. Other forces is called M2G and which has a reactions called N2 and its acceleration is in this directions A. Any other forces are there? No. This force will not come here. This force is capital F. Capital F is applying only M1. Okay, capital F is only applying on M1, not on M2. And this F is actually converted into what called contact forces. So you only look into here and you see any other forces are there. No other forces. This F is only for M1, not for M2. So we got this one. Now we have to write sigma Fx equal to Ma and sigma Fy will be equal to Ma or 0. Okay, so sigma fx. Okay, we'll write sigma fx. I am not repeating the sigma fx again and again because it will lot of time if I am telling this one at the end of the chapter, around 1000 times I have to tell. Okay, so we will directly write to the equations for x direction. So x direction equation. So x direction equation is what? F is positive direction. F will be equal to no other forces. F is equal to mass into acceleration, which is called M2A. Equation number third equation. We have given 1 and 2, right? And then in y direction means this equations. So M2G downward and N2 is upward. So N2 minus M2G. If body is moving in this direction, it's not moving. So acceleration is 0. So M2A is not there. So this is equation number 4. This is a way of drawing the free body diagram, and this is a way of writing the equations. Okay, so there are different values will be given to you in the question, and you have to find out the answer for this one. Okay, answer in the sense mostly if they are asking what is called contact forces. So M2 value will be given to you and you have to find out A value. So for all these questions, the main intention is you know how to draw the diagram. That's the first step. And the second step, once you know how to draw the diagram, the second step is you know how to write the equations. Once you know how to write the equations, you have to solve the 4 equations. From first diagram we have 2 equations, from second diagram we have another set of 2 equations, and we have to solve. And one important point, before going to do all these steps, the ultimate point is we need to find out acceleration of this body. So how to find out the acceleration? Okay, we know Newton's second law of motion, right? F will be equal to ma. So acceleration of the system, if you consider the complete system, complete block, acceleration is equal to F net divided by m net. F net means net force or total force. M net means total mass. So what is the total force acting on the complete system? Only this F. So F. What is the total mass in the system? M1 plus M2. So you have to write M1 plus M2. So this is another important thing with respect to the other than with respect to 1, 2, 3, 4, and this is our the 5th equation for us. Okay, this is our 5th equation. So similarly, so in this case we find out acceleration, total force divided by total mass. Always it's like that, total force divided by total mass will be equal to acceleration F net divided by m1 plus m2. That is a concept behind this problem. Suppose if there is one more block will be given, what you will do? Now here only 2 blocks will be here, right? If there are 3 blocks will be given, what you will do? That is also again simple. Okay, so I will just draw the 3 block cases. Okay, we'll draw the 3 block cases. So this is a 2 block cases, and we'll move to the next one, that is for the 3 block cases. So if you know the 2 block cases, 3 block is quite easy. So we'll move to the example number 2, second example. So we have 3 blocks, first block, second block, and third block. So it's M1, this is M2, and this is M3, and this is all over the surface is there resting and with a force called F. So we have to write all the forces. So I am assuming the contact force here. If we have only 2 bodies, I just consider small letter F, but here I am considering small letter F1, and here also one contact force, small letter F2 will be here. Okay, now we will draw the free body diagram of M1. Okay, you can draw along with me, and this is called a capital F, and this is called M1G, and this is called reaction N1. Any other forces? Yes, one more force will be there, this contact force, and this F1 is acting towards the body. This is the diagram of M1. Okay, and we can draw the free body diagram of M2. Free body diagram of M2. Can you tell me what is the free body diagram of M2? So M2 body is drawing here. M2. What are the forces? Both side contact forces are there. So F1 is towards right, towards the body, and F2 is also towards the body, because both are called contact forces. And M2G is in the downward direction, and its reaction is N2. One more thing I forgot to mention here. What is called acceleration? A direction. It's moving left to right. So here also accelerations. So 2 set of diagram we have drawn and 2 set of equations we have to write. M3 is also there, we will write it further. Before that I am going to write acceleration, total force by total mass. So I am considering the complete system in one shot. So total force is F, total mass is m1 plus m2 plus m3. This is the way we can find out the acceleration. Now we will write will be here x equation, x set of equation. Tell me F positive, F1 is negative, F minus F1 will be equal to m1a, acceleration is positive, equation number 1. In the y direction, n1 is positive, m1g is negative and no acceleration, so it is equal to 0, equation number 2. So 2 equation we have written. We'll come here. F1 is positive x direction, left to right. So it is positive F1 minus. F2 is in the negative direction, so which means minus F2 will be equal to m2 times of a, acceleration is in the positive direction. Always you have to remember the Cartesian or xy axis system, minus x and plus y, and this is minus y and this is plus x. So if it is from positive x direction means positive, negative means negative direction. In the y direction. So this is our x equations and we are going to write our y equations. What is our y equations? N2 going upward, correct. So N2 minus of M2G. Body is moving like this? No. So it is equal to 0. Equation number 3 and equation number 4. So 2 free body diagrams I have drawn, and I have also drawn the 2 free body diagram and 1, 2 and 3, 4 equations. It is not necessary a body mostly will have only 2 equations, x direction equation and a y direction equation. Now what is left will be here free body diagram of M3. So we have to draw the third. So 2 free body diagram and we have a totally 4 set of equations, and we will go to draw the next one, which means free body diagram of M3 in the free body diagram. So we will draw the body M3. Tell me the forces. M3G downward, we know. Upward is called N3. Then what is called F2, contact forces always towards the body, F2. One more thing missed. What is that? Acceleration. Correct. Okay. Next thing, what we need to do, we need to write the x and y equation. So I am writing the x equation for this one. F2 will be equal to m3 into a, equation number 1, because body is moving, F2 is positive, total force equal to acceleration, m3 into a. What is the value of a? It is given there, a equal to f divided by m1 plus m2. Next one, y direction equation. N3 is positive, so n3 minus mg is equal to 0, equation number 3, 4. Okay, so this is equation 5 and this is equation 6. So totally 3 bodies are there. I have drawn 3 free body diagram. I got totally 6 equations. So it doesn't matter how you are drawing and how whatever you are doing, in the sense like the direction is important. Okay, so depends upon the number of diagram, depends upon the number of bodies. If 2 bodies are there, it's quite simple. If 3 bodies are there, little bit complexities are there, but in short it is quite simple. So always this model of questions, if a question is coming like this one, then the ultimate aim is to find out the value of acceleration. I am not writing correctly. A is equal to f divided by, okay. So the ultimate aim is to find out, the first step is to find out the value of acceleration is the first step. Then we can go with this all other steps in this model of question. Question is, it is not necessary it should be always in this model. There are different models are there, different examples are there. We are at example number 2, right? So further examples also we will see the different models of this one. So hope these two, like 2 body cases and 3 body cases which are in direct connection. This I told mainly an example of something called the contact force. So we have learned about 3 rules, right? First rule is contact force are towards the body. Second rule is called tension forces are away from the body. So that we yet to see. And the third one is tension into acceleration is constant. So that is also yet to see. So this is just 2 examples based on the first rule.